Alright, this is Mr. Gillum. Today we're going to talk about parallelograms again. And today what we're going to actually do is we're going to add those two-column proofs that I know you guys love. And they're very similar to the ones that we've done in the past. But unfortunately, there's some of the theorems that we don't have just nice, like fancy names for, like angle bisector theorem, things like that. We're going to have to do some shorthand, but that's okay. So today we're going to practice writing two-column proofs, and we're going to use the theorems that we learned about parallelograms yesterday and their diagonals. So let's take a look here. We're going to start by writing a two-column proof. What we're trying to prove is that angle F is congruent to angle H and angle J is congruent to angle G. All right, given that FGHJ is a parallelogram. So just that information alone tells us several things. The definition of a parallelogram is that it has two sets of parallel sides, and they are opposite from one another. So I'm going to go ahead and draw that in. That's what the definition of a parallelogram is, and that's all it gets you. Okay, we know things about it from practice yesterday. We know that G and H are going to be supplementary. We know H and J are going to be supplementary, F and J, and so on. And we also know that F and H are congruent. But today we're going to prove that they're congruent. So we can't just say, oh, well, we just know they're congruent because the theorem says so. No, can't do that. We're going to have to use properties of parallel lines that we've done in the past. So let's take a look here. First, we're going to start out with the given, and that is just that the parallelogram FGHJ. And I gone ahead and drew the little lines on there that we need. Okay, FG and JH are parallel, as well as FJ and GH. Oh, did I say the same thing again? FG and JH and FJ and GH. Ugh, that's confusing. Anyway, the two pairs of opposite sides are parallel. Okay, so that's definition of a parallelogram. That's all you get. You just get the parallel sides. You don't get to say, well, angle J and G are congruent. Nope, that's one of the theorems. The only thing you get with the definition of a parallelogram is that you have two pairs of opposite sides that are parallel. All right. Now we're going to do a three stacker, and we're going to put it all on the same number, like the third step, because it's the same proof on each one. It says if angle F and angle J are supplementary, angle J and H are supplementary, angle H and G are supplementary, all these are supplementary. So I'm looking at these, and what I'm saying is they're supplementary. These guys are supplementary, as well as J and H and G, and I could even say F and G are, but that's going to be too, we don't need that information so much. And what it says is parallel lines are cut by a transversal. Consecutive interior angles are supplementary. So it's saying, okay, if these are parallel, and these are parallel, this transversal right here guarantees that our consecutive interior angles are supplementary. Okay, and I think what we did was we abbreviated that. You can just put consecutive interior angles theorem of parallel lines. Okay, so we're just going to abbreviate that way. This is too many words to write down. Consecutive interior angles theorem says that the angles are supplementary if they're next to each other on the inside and the same side of that transversal. Okay, and we practiced that yesterday. And then finally, we know if angle F is congruent to angle H, because if two angles have the same supplement, they must be congruent. All right, so these kind of remind me of paragraph proofs, because each step that you take to get to where you're trying to go, and you're trying to prove angle F is congruent to angle G, or F and H and J and G are congruent, each step that you take is almost like, oh, well, I just need to explain myself anyway. And a lot of times when you're explaining over here, it's going to be an if-then statement, a conditional. Okay, and I know there must be congruent because supplements of the same angles are congruent. So I think you guys are going to do a nice job on this. This next one's even shorter than this one. I know this is only 4 steps. Really, this one could be separated into several steps, but it's the same theorem every time. Okay, you just need to use a strategy to get to where you're going. And this guy, okay, we're given that HJKP and PKLM are parallelograms. So what I'm going to do is I'm just going to put on here my parallel lines here, and I actually just did that, but I can't really, I know they're parallel on both sides, like so, and I actually just pretty much gave away the proof when I put this the same mark on each one of these. All three of those must be parallel, and that's what we're trying to prove. Hj is congruent to ml. We need to know that, first of all, we're going to use the given. Parallelogram HJKP and parallelogram PKLM. We're given that there's two parallelograms. All right, so let's start right. I think I'm going to switch colors here because I think it's kind of hard to see. I'm going to go to yellow. Now, we know things about parallelograms. What we're actually trying to do is prove a congruence right here. We're trying to prove that two of these side lengths are congruent. And so to do that, we would have to show that Hj is congruent to Pk, and therefore Pk must be congruent to Ml. Well, we can do that because we know some theorems about parallelograms. We know that their opposite sides are congruent. So what I'm going to say is that Hj is congruent to Pk. And I'm also going to say, kind of like on the last one, we combined those three things because they were all the same step. I'm also going to say that I know Pk is congruent to Ml. And I know that because if we have parallelograms, their opposite sides are congruent. So what I'm just going to write is opposite sides of parallelograms are congruent. Opposite sides of parallelograms are congruent. So I'm just going to abbreviate it that way. Okay. But this is good because if I'm trying to shoot for Hj is congruent to Ml, what I really need to do is I need to say, well, congruent, this is kind of like one of those little ticky-tack things in your proof. We know congruent means the same thing as equal, so I'm going to say Hj equals Pk and Pk equals Ml. I'm going to say that's the definition of congruence. And then I'm going to say, well, if I know Hj equals Pk and Pk equals Ml, through the transitive property, Hj must be equal to Ml, or must be congruent to Ml. So therefore, Hj is congruent to Ml through the transitive property, 1, 2, 3 RST. Okay, and I'll just remind you that 1 equal sign is the reflexive, 2 is the symmetric, and 3 is the transitive. Okay, and so I've proved what I'm trying to prove, and this was the main one from yesterday, the main theorem that we learned, that opposite sides of parallelograms are congruent. And so just depending on what you're trying to prove is going to kind of dictate where you go with your proof. If you're trying to prove angles congruent, you're going to use some theorems about the angles of parallelograms. So it's just kind of help you steer in the right direction. So that's it for today. We're going to do proofs on Tuesday, and that's it for today.